will share the presentation as well. And then I think your assignments for 1610 is opening today. And it's normally open for the week up until normally the Monday. So we will have another session on Thursday to just do nearly a summary of study units 6 and 7, and then on Sunday morning as well, again at 9. But I will share the links with you on the WhatsApp group. We will have another session so that you are prepared for this assignment. And then just for the guys not yet on the WhatsApp group, there is a link again in the chat for you as well, and just click on the link. Else, as always, you can send me a WhatsApp, and I will add you to the group. Okay, so today we're gonna focus on chapter 7. So it's nearly the next step from looking at normal distribution. So in chapter 6, we started looking at the normal distribution, but when you look at chapter 6, we were looking at more from a population standard. So when we looked there at the questions, we never were nearly worried about the sample size of it. There's never questions about the sample size because we just looked at a normal distribution or a distribution that were acting like a normal distribution with a mean of 0, standard deviation of 1. So we didn't really worry about sample. So in study unit 7, what we are adding to this is to bring in the sample dimension. So what you will see in a lot of questions is that they will say that the sample mean, sample standard deviation is something we want to work out how the measurement that we will have, the X value, differs from that. So that is nearly what we are going to do in chapter 7. It is nearly the whole time going to look at the sample distribution. The one big difference coming into chapter 7 is that we will have sampling distribution for the mean. So where we will look at the Z, and I'll show a few slides now, where we will look at different around the Z where we know or get the mean, and then we will also look at proportions. Yeah, I'm definitely, we are recording. I will send the recording afterwards. So don't, yeah, if you're experiencing network issues, also for the guys that need to leave at a certain time, don't worry, I will share a recording and the presentation afterwards. So don't worry at all. I know there is some areas that are having issues again with some of the networking and things like that. And weather in Cape Town is starting to change as well. So let's hope it doesn't affect. And so we're first going to look at the mean, and then we're going to look at the proportion as well. But again, you will clearly see out of the questions when we're dealing with the mean and when we're dealing with the proportion. So just again, a few technical things that we need to take into account, especially also when there might be some definition questions again. So the first thing is, and this is more on the sample mean, is that the important thing around the sample mean, and we're going to use the sample mean and sample proportion in study unit 8. We're going to use it in study unit 9 as well. So it's not that we're only going to use it in study unit 6. When we do confidence intervals, we are going to look around the confidence interval around the sample mean. We are going to look at the confidence interval around the sample proportion. So we will have that in chapter 8. Then when we go to chapter 9 on hypothesis testing, again, we will have hypothesis testing that we will do with sample means, and we will have hypothesis testing that we will also do with proportions. So again, a very important chapter, chapter 7, because we are using it in chapter 8 and 9. What also important nearly is that the way that we work out the Z has now changed slightly. So when we were looking at population, the formula for the Z was just your X minus your mean divided by the standard deviation. But the one thing that now changes, because we're working with a sample, is that with a sample, a slight change, and that is where we bring in that size of a sample. So we will bring in that as your standard deviation divided by the square root of n. Okay, so that is the only change between when we worked with in study unit 6 from the move to study unit 7. So from the population normal distribution going to the sampling, that is the big difference. And then the other thing that sometimes they mention in the summary, sometimes not, but what is also important, this component that we are working with, so that component is also called the standard error. Okay, so there it is. So because I have included one or two questions where they give you all the information, but they only want you to work out the standard error. So again, we will go through one or two of those examples where we're really focusing on you just working out the standard error. The same in the proportions. When we look at proportion, there's also a standard error with proportion, and this part at the bottom again is your standard error. So you get your standard error for your proportion. So just again, there is the two standard errors depending on if your sampling distribution is known or not known. But again, remember the standard error, because they love to ask standard error, and it might also be, I think the other important thing is where they give you all the information that you nearly work out that Z. One of the answers is also the Z, but you only needed to work out the standard error. So just be very careful again with what they are asking, and what is all the information that they are giving you. So again, also I will, in the next week or two, I will send you guys also a formula sheet that covers all the work nearly, that you again don't need to jump between slide packs or study guides and things like that to get to your to some of the equations or formulas that you need to use in for the stats. So okay, so important things out of this chapter that they will ask you in questions is still to work out the Z. So they can ask you to work out the Z, then they can ask you, like, and we show that a few times in the previous session, but again, I'll show you, if you get the Z and you need to go to a probability, are we going to do that? So they can do it with the sample mean, or they can do it then, let's just see why this is not up. So they can do it with a sample mean, and they can do it with the population proportion. So we will have a few question on both that we will go through, and also then just I will share it again later tonight, but also just opening up the table that is also one of your study letters, so that we get to nearly that tables that we're going to use. So again, we're going to reference the tables, the normal distribution tables. So nearly the flow from study unit 6 into study unit 7. A lot of the things that we've done in study unit 6, we are going to use in study unit 7 as well. Okay, so let's get going with some of the questions that we can see what they're asking. Again, some is out of the study book that you have. some is from previous assignments that that was sent to me by students. This one, again, something that we did last time, but I want to bring this in as well. So yeah, we will go through a few different types of questions, different things that we need to work out. Okay, and also for you guys again, remember when you're doing the assignments are open book. You are allowed to have your study guide with you. You are allowed to have my slides and things with you. So please use nearly the slides, the study guide, all of those things. You are allowed to use. You are allowed to use different calculators. You are allowed to use Excel. So please, for assignments, do that. Okay, so let's look at this question, and let's see what they ask us. So they tell us a sample of n equal to 16 observations is drawn from a normal population with a mean of that, standard deviation of 200. Use the standard normal Z tables to calculate what is the probability that X, or the mean, is bigger than 1050. Okay, so they want us to work out the Z that is bigger than that. So let's just first write out the formula so that we can just get used to seeing that, and then we can just substitute. Okay, so probability that Z is bigger than the mean of 150 minus 150, 1050 minus 1000, and hopefully the other one works out nicely with division. So 200 divided by the square root of n, so the square root of 16. Okay, so 1050 minus 1000 gives us 50. 200 divided by square root of 16, so 200 divided by 4 gives us 50. So we're sitting with a probability that we will need to work out Z bigger than 1. Okay, so then you see this is what we did in chapter 6. So now Z bigger than 1. Again, firstly, let's draw the graph. We know that is 0. So again, don't need to be on scale, but what we know is that 50% of probability is sitting to the left of a 0, 50% to the right. So when I'm looking at answers again, I know that this piece is going to be less than 0.5. I don't know the answer yet, but it's going to be less than 0.5. So if I want to eliminate answers, it's not that, it's not that, it's not that. Okay, so just by getting to the Z and looking at the diagram, we have eliminated free of the options already. Okay, so let's look at how we're gonna get it. So first thing I would have done is to say, well, I know that from chapter 6 this is symmetrical. So if I get this piece of -1, that areas will be the same. So we can go to the negative table. Let's zoom in. So -1, there it is 15 point or 0,1587. So we can do it that way. So 0,1587 is that portion. So we know because of the symmetry, it will be the same. The other way we could have done it is to say, well, this orange portion, how we're going to work it out is we're going to use the positive table. We're going to look at what is positive n of z equal to 1. But then remember, we sit with a green space. So we need to say 1 minus that green space, and that must also give us the same answer. So we can go to the positive table, go to +1, so 0.8413. So if we subtract 0.8413, we get the same answer, which is 0,1587. Just be very careful again, because look at 8413. So if you read it wrong and you worked out that area, there was an answer. And again, I think that is important for you guys, is in this one they said bigger, so we know bigger than 1. Again, what I shared last time, and let me just add that quickly. Sorry for, I should have added it. Let's just add that other table in this one, so that again, when we get to all of these questions, let's see where I can put it, that we just have it again as part of our set of things. So I just want to add it in again, that we have it, so that when you guys need to reference it in words, because again, I am fine when it is shown to me like this, but when they start using less than, more than, bigger, more than, then I rather use that table and make it easier for myself to know what to do with a question. Okay, so this one was, they gave us information on the x, the mean, standard deviation, and n. They wanted us to work out the z, then go to your z table to work out the probability. Okay, so that is the traditional questions that they love to ask, where they give you the information, you need to follow the steps. Then we will nearly repeat that process when we get to proportions, because it will follow nearly also. They give us a proportion, they give us a bit of other information. So that is normally the full-on process that we will cover to from the information given, working out Z, going to the Z table, getting a probability. But what they also do is sometimes they give you the information. So they tell you we've got a sample mean of 40, we've got a standard deviation of 12, we've got the sample size, and then they throw in, but all that you need to actually work out is the standard error. So all that you need to work out is that piece, that is this, the standard error. So if we look at the full formula, the standard error is only this part that you will need to work out. So they give us more information than just that. So yes, there is the sample size, there is the standard deviation, but they've also given you the mean, just again to nearly make you think, but what am I missing? And sometimes they can add an option as not enough information given or something like that. Not that they're going to say none of the above. They sometimes add in to say not enough information, because nearly thinking, okay, but if I needed to work out the Z, I need something more, but we actually are only looking for standard errors. So standard error is standard deviation divided by square root of n. So in this instance, it will be 12 divided by the square root of n, which is 100. So it will be 12 divided by 10, which is 1.2. The other thing that they also sometimes do is will tell you the variance is equal to a number. So just remember again, if they give us variance, that the standard deviation is basically equal to the square root of the variance. So if they give you variance, just remember from chapter 3, I think, we go back that way, from chapter 3, the work where we looked at standard deviation, we looked at variance, that if they give you variance, just remember the square root of the variance is the standard deviation. Okay, so again, nearly just wanting to show certain things that they might love to ask, like to bring into the equation, and things like that. That you just again know what might be coming with some of the questions that you guys will be facing. Okay, so let's go into the next one. So a bit different to the previous one. So if you look at this one, the big difference is now they're using words. Other one they showed you need to look at x bigger than a certain number. Now they're using a few words. So from a random variable that is normally distributed with a population mean equal to 80 and a population standard deviation, what is the probability that a simple random sample of 25 items will have a mean that is less than 85? So we want to work out the z that is less than, let's just quickly check, less than is that. So less than, and let's write down the formula so that we nearly get just used to what we're using. So that is what we want to work out. We want to work out what's the probability so that your z is smaller than the x minus the mean divided by the standard error. So here we have, they say less than 85. We know that the mean was 80. So I just know, okay, that will be, when we get to it, 80 minus 85 will be 5. So let's look at standard deviation was 10 divided by square root of 25. Square root of 25 is 5. So 10 divided by 5 is 2. So we're looking at a probability of less than 2.5. Okay, so again, quickly draw it because that again might give you options to cancel out. That in the middle is 0. So we need to work out less than 2.5. Okay, so we can see that whatever we're going to work out is going to be bigger than 0.5. Because that portion is 0.5, we will add another portion, so it will be bigger than 0.5. So let's quickly, bigger than 0.5, yes, bigger than 0.5, yes. That's smaller, that's smaller, that's smaller. Okay, cool. So actually eliminating 3 of options. So let's again use both. So first, because we're looking for this area, which is nicely represented by the positive table, we can go to the positive table at 2.5, and we will see the answer that we're looking for is 0.9938. Sorry, wrong. So we know that that now is 0.9938. Okay, so that was option 2 is the correct one. If we wanted to work with a negative table because we wanted to work out this area, it's fine. Just again, remember, we're going to say 1 minus this small area. But I want to show you guys. So so that we just get used to using both tables. So negative 2.5. So because we want to get to that small area is 0.0062. Sorry, 0.0062. And you will see if you work that out, it is exactly the same. You get the 9938. That will then be that whole area. Just again to nearly flag it that if we only have looked at the negative table, your 0.0062 is also given as an option. So just again be wary about which table you use, which table you're comfortable in using, because they will always nearly give you the option of both tables. So even if we look at this one, there was, like I said, there was the option of the other table. So just be very careful with all of the questions around chapter 6 and 7 when we need to work out the Z, and from the Z the probability, that the chances is very good that they will give you the Z value of a negative table, or sorry, the probability of that Z value they will give from a negative table and the positive table. So just be very careful when you guys complete it as well, because again, you are under time pressure. You see the number that you are looking for nearly, or you see a number that is in the table and in the answer set. And sometimes one just quickly before reading make decisions and then get it wrong. Okay, so those were 3 questions on sample mean. So we will do a bit on sample proportion as well, and then we will just look at examples from previous assignments. And then if anybody, it's strange that the quiz, because there's normally a quiz that you guys can also do. So if anybody has done the quiz, please send it on when. Oh, okay. I obviously have missed. Did you send it to me or to a group? Then at least I know. Okay. Obviously, I missed that one. I will. I think let's. Cool. Thank you. I've seen it. I will. As we're speaking, let me also email it to me. Then we can go through that on Thursday. So that self-assessment we will definitely go through on Thursday, that we cover that. Yeah, then at least if you say it's tricky, that's probably how they will look at some of the assignment questions as well. So let's just make 100% sure that, yeah, we'll do that self-assessment on Thursday. We will go through that. Cool. Okay, so I'm I'm always worried about these self-assessment questions and what they are asking in it. Um, the one thing that just between us is that your self-assessment questions and your assignment questions are normally more difficult than the questions in the exam, because they want to make you think a bit more. The problem with the exam is normally the time. So the big thing with the exam is normally the time that you're getting to complete it. Okay, so let's look at this one on sample proportion. And but first I normally first want to just copy the formula. So let's just, even if we copy this whole, I will crop it in, because again, it's not something that you guys need to remember. You don't need to know the formulas off by heart. You can use your study guides and textbooks, and I will see where some of the formula sheets are as well. So please don't nearly try to remember the formulas. So sample proportion looks a bit different, but still it is, if we compare it to the sample mean, nearly, you've got your X, you've got your mean. So there's always the things that you're going to test against. And then you have your nearly, and think back to, sure, study unit. When did we do binomial distributions? Because that is what a proportion is, basically something happening, something not. And look at that formula, and you will nearly see a bit of that in your variance component for binomial. So we've got the standard deviation here for the proportion divided by n. So that standard error just a bit different than the normal one that we work with, but you can see the links nearly between the proportion and the mean and how we got to it. So what we're again asking us, so in a binomial experiment, sample size, so we've got sample proportion, the standard error for the proportion. Okay, so they want us again to work out the standard error. So from that slide, you would also have seen where sometimes we talk about the standard error of the proportion, when it is known, when it is unknown, but the process is similar. So you want to work out the standard error. So you're going to use this part of the formula. So we will substitute this by with a pair the P or the pi, or however you want to pronounce it. And I automatically just set 1 minus 0.5, but I will give you 0.5, but to just put it again in the terms of the formula, it is 1 minus the 0.5. So in this instance, that answer will also be 0.5, and we divide by n, so they need to give us n, and then where for the mean it was the n square, we now need to nearly do it for that whole thing. So that is the standard error that we will need to work out. Okay, yes, there's a question.
Hi, Jean. Sorry, I might have missed. I was in the previous class that we did. I think it was study unit 6. We had a formula for Z. I wanted to understand, what is the difference between this Z that comes with this formula compared to the other Z? How do you distinguish which one it is? Sorry, it might sound basic, but no, I'm just lost there. Yeah.
So when we start to talk about sample, then it is when you bring in the formulas that we are doing tonight. So you would, and let me quickly open that presentation of chapter 6, so that you can see. So when we did chapter 6, there was never, it was always the talk of normal distribution. They give you a mean, they give you standard deviation, but they never said anything about the sample. So it was nearly always assumed that we're working with the population, even though they don't tell you population. They've never given you an idea that you're working with a sample. So whenever we're working with the Z and they don't talk about sample, we will use the formula as we did in chapter 6. So that is nearly the big difference, is that in chapter 6 it was all about actually the population that we always worked out, even though they didn't say it. In chapter 7, what they will say clearly in all the questions is that you're working with a sample. So that is nearly the big difference between chapter 6 and 7, is in all the questions that you need to nearly work with these formulas, they need to tell you you're working with a sample. So a sample of a normal distribution, standard error with a sample. So otherwise, you assume it is a population. Okay, so if I don't tell you you're working with a sample, you assume it's population and you use the formula that does not include the n, and you just say x minus the mean divided by standard deviation. Okay, so, but when we start talking sample, that is where we use these formulas from chapter 7. Okay, and it's a good question, because for your assignment, you're doing, it's chapter 6 and 7, so you need to nearly know when to use which one, because you don't want to be in a situation where you want to use this, you don't have a sample, and then you say, but I don't have enough information, and not be able to do it. So it is nearly, the rule is we use the Z, the standard one, as your way to answer it, unless they tell us it's a sample. Then we use or the sample mean or the sample proportion. And so that is how also when you do assignment 3, be on the lookout for those things where they say it's a sample, or they say it's a population, or they don't say it's a sample. So please don't assume that everything needs to be around the sample. There will be definitely questions from both study units, and that also makes it tricky, because it's a very easy way to trick you in getting to the answers, because dividing by standard deviation and dividing by standard error, sometimes the difference is very small, so that you could merely be using any, or get to the two different answers that are very close to one another. So again, yeah, that is quite important. Okay, so let's look at, so for the sample proportion, okay, this is calculated time. Where is my calculator? I think it disappeared somewhere in the house. So let's just, I'm gonna quickly do it on Excel, but it's just because I don't have my calculator with me. So it's not that it's because Excel is better. It is just because, let's quickly do some, it will be that one. I'm gonna say hopefully this will work out. That times that divided by that square root, it seems like it. That was with 3 blocks. Okay, thanks. So hopefully we get to the same answer. Awesome. Okay, so 1, 2, 3, 4. So let's just make it to 4 decimals. Okay, 0,028. Oh wait, your sure. Okay, so that 028. Sure, that is so close. Why don't I just want to check it. 0.5, 300. Okay, so there is a bit of a. Okay, wait, let's just close it for now. So it is very close to the answer, 0.02. So if we rounded it off one more, I get the same as you. Yeah, I hate this because I know it need to be that one, but it's not 100%. Yeah, so it's not 100% the same. So somewhere, obviously, they changed something on their side and did not update this. So up until that point, it is correct. The other ones are just not close enough at all. So yeah, the answer is 1. But again, if you guys see something like this in your assignments, you let me know, and I will tell the lecturer, and they will throw. Oh, okay. How are you getting? Okay, see. So be careful with the calculator in the steps that you are doing, because it might be. So let's quickly. I see this hand, so I'll quickly. But if if you take square root of a 1, okay, so it's 0.5, 0.5. Okay, so share with me how you got to the 0.2886. Just would be interesting to see, or which calculator. So even if you take a screenshot of what is in the calculator, but Albert, you can chat as well. So
all right. Hi John, what I did with I'm using a Casio calculator. So
yeah,
I pressed the square root. I think that's the second
okay.
row. From there, I pressed the first button on the left, and then I typed in the 0.5, and then open the bracket, 1 minus 0.5, close the bracket, and then divide by 300. And so everything is under that square root. Then it gives me the number 5.
Phew. Okay, so that so that is interesting that it does that. So what I just want to check if it is that it does it because it was something like this. No, so okay, so yeah, okay, so that is okay, cool. So that is what you've got. Okay, so just look at, so you got that. Look at 5 and how they want to catch you out. So it's just they catching you out there. There's a 0 missing. So very easily you saw it 2886, 2886. But look at where's your comma and where's that comma. That is a perfect example nearly of them trying to catch you out. So just by moving that comma one place, you would have gone for option 5, even though you actually had the right answer. So again, it's sometimes what is difficult with this subject is not always sometimes the subject matter. It's sometimes how they nearly look at what the mistake students make a lot, and then they bring that in. So again, very easy to make that mistake, because you see your 2886, you see your 2886, you don't see your 2886 anywhere else, and you're using that. So just be again very careful where the comma is comparison to that. So this is not nice because number one, it should be the answer, but we there is actually not a one that is straight on that we wanted to get to. Okay, so another way that they can ask this is nearly in a way where they give you everything. So, and then you nearly need to check everything. So let's see what's the things that they ask us in this one. So they're talking about the sample proportion that you need to work out. They talk about the standard error. So they talk about that component. Then they talk about the test statistics. So the Z that we need to work out. So let me quickly just then they talk about the probability. So if we get the Z, we need to go to the Z table and see if we have a probability. And then they also talk about some bit of a definition. So let's first look at sample proportion. So sample proportion, how we will normally work it out is by saying, so what is your observed values divided by the total sample. So here they tell us the number of observed successes is 96. So 96 divided by 400 will give us that p-value. Okay, so that p-value 96. Again, I don't have my calculator, so let me just say 96 divided by 400. We get 0.24. Okay, which is that one, but we're looking for incorrect, so not that yet. Standard error, the bottom part that we need to work out. We've got the pi is 0.2, so standard error is 0.2 times 1 minus 0.2. divided by n, and this, and the square root of it. So that will be your standard error that we're working out. So again, the Casio and the Sharp will be easy to work that out. This is normally a bit more difficult on the one I have, the HP, because then you need to nearly put in some of the things in its memory before. So sometimes the HP, even though I like my HP, the other ones are better. So if we take the square root of the standard error, the answer I get is 0.02, which is what they're giving us. So unfortunately, still not the incorrect one. So that means we need to work out the Z as well. So let's work out Z. Z is equal to P minus, so we've got 0.24 minus 0.2 divided by, and at least now we already worked out that standard error, so we don't need to work it out again. It's 0.02. So if we work out that, it is equal to 0.24 minus 0.2 divided by 0.02. The answer that I get is on the dot 2. Again, a silly one, because okay, so that is then the incorrect one. I don't like questions like this where it is nearly playing on all of these point twos, and really not a great one. But Z is 2 and it's not 2.02, so that is the incorrect one. But let's also work out your Z, the probability. So the probability there, they told us bigger than the 0.24. Again, that will be 0. Somewhere there it is 2. So we're looking for that area that we need to look at. So again, we can do it both ways. Negative table to get to -2, and then it is exactly the same for the +2. So that the first one, so -2, -2, 0.0228, 0.0228. So that is correct. Or we could have gone the route to say we using the positive table, but then it is 1 minus this green area, which is the positive table. So if we do that, +2, so 1 minus 9772. Sorry. So 1 minus 9772 will also give you the 0,0228. Okay, so again, can use different tables to get to that area. And then the last one was this case of sampling distribution of proportion. I think they actually call it so binomial population with a population proportion that, and we're working with a sample, so it is sample distribution of proportion. Okay, yes, there is a hand. So
yes, on that number one.
Yes.
What's the equation there of that sample proportion?
So to work out the sample proportion, it depends on what we are working out. So here we are working out the successes. So it's basically the number of successes divided by the sample size. So that is the 96 divided by the 400. If the question was that the number of not successes, if there is even such a word, then it would have been the rest of that. So like in binomial distribution that we did in chapter 5 or something like that, remember there was always a success and a failure nearly.
Yes.
So in this instance, also just be very careful when they phrase it. So normally they will phrase it in the positive. So the successes, or let's not say in the positive, but what they want you to work with is in the wording as well. So in this instance, number of successes, when they give you the successes, it might be the number of bulb failures when they give you that number. So that is how we will work out that sample proportion, is that they again need to tell you what we are working with.
Okay, good. Thanks, I've got it.
Cool. There's another hand.
Yeah, I did not get what the test statistic is. Did we calculate that? Yeah.
So the test statistic, all that we are actually calculating is the Z. So again, something that they sometimes throw in is just to say work out the test statistic. Again, we're going to see that a lot in chapter 8, 9, and 10 as well. So actually what you're working out is the Z. So you're working out what is that Z value. So again, by bringing in the terminology of the test statistic, because when we get to chapter 9, when we do hypothesis testing, we're going to always test against something. The same when we do confidence intervals, there's going to be some other Z values that we also bring in. So the test statistic is basically the Z value that you're calculating. Okay, so yeah, so they could have just said to us, work out the Z, but yeah, you guys will see in the later study units, especially in 9 and 10, where we need to make a decision with hypothesis testing, there we will bring in another Z value nearly that you're going to test against always. So this one that we get all the information, we call the test statistic. Okay. But it is actually a Z. Okay, so that was the one that was wrong. Again, I hate it when it is something like stupid as 2.02 versus 2, because sometimes you actually don't know, and this was some of the pre-COVID stuff, when it is a mistake, a typing error or not. So again, at least with currently with your lecturer, it's when you guys are doing the online assessments, and you pick up things, you let me know, because I will let him know. He looks at it, he will say, oh shucks, there's a mistake, we throw out the question. If it happens in the exam, exactly the same. So it is one of those where I think this is one of the subjects. It's not the easy subject, but at least it's a subject where the e-tutors and the tutors have direct access to the lecturer. So so again, yeah, the 1610 one, please, if when you have and you're picking up things that even if you think it is wrong, you let me know. It then it might be that it was read wrong, or you used the population instead of the sample, but at least you don't nearly be afraid to ask the things. If if there is a question that you see it's not working out, and you think there's an error in the question, just let me know, and I can easily let the lecturer know. Just check question 3 or something like that, and I can quickly let you know about it as well, that when you know at least if it was an error or not. Okay, so let's look at another one. So consider population, proportion, and work out the standard error. Okay, so basically, again, if we work out standard error, it's the pi times 1 minus that. And let's hope this time the answer is one of the options divided by 20. Okay, so that at least give me, if you're getting one that is at least okay 1 comma or 0,1043. Yes, I'm getting the same on the calculator. Option 1. Okay, so at least there was no problem with that. But again, look at just how close some of these things are if you misread the calculator again. Some of it totally wrong, but also if you did not, I think if you didn't square root, there's probably an answer for you as well. If you didn't square root, that would have been your answer. So nearly at each step, if you, I just want to check this. So if you said 0,68 times the 0,32, because that's that step, your answer would have been, so if you only did that component, that would have been, your answer would have been 0.2176. Okay, if you divided that by 20, your next answer would have been 0.0109, which, and only then if you do the square root of that, you get to the right. So again, depending on if you use a calculator, if you use something else, it is one of those, and that again, I know out of experience, you under pressure in the exam. Assignments are a bit different because you've got more time, but you under pressure in the exam, you just put in that and you're like, oh, got it. And it's like, okay, but there's a next step. Okay, maybe you do the next step. Okay, there's the answer as well. So sometimes it's not in the difficulty of the questions. It is just that we make mistakes because of pressure. So, and that's why for you guys, I know there's lots of issues with the UNISA platform, with the assignments. At least all the exams are done now. So hopefully the platforms must not give you that much problems at the moment. Hopefully, touch wood. But track, like with the self-assessment, if there's more than one self-assessment that you can do it. When you do the assignment submissions, don't, even if you get 100 for your first attempt, do another attempt. That 100 will be what you will be getting, but it's more to see what other questions that they ask, and because that is normally where the most mistakes are nearly being made, is just to see how they can phrase it differently. So yeah, like you said, it's hectic because it's nearly, there's free, in the 3 steps that we did, there is the free answer. So sometimes it is just more around trying to catch you out than anything else. Okay, I needed to include this because this is one that was done last year, and what it does is nearly, and you would have seen it in assignment 2 and 1 as well, it's nearly throwing the question upside down, that you're nearly working backwards. So they're telling us in this question, the emotional intelligence quotient, so let's just say EQ score of a grade 8 class, is normally distributed with a mean of 80, standard deviation of 20. So if we just look at that formula, they talk about samples, so we can automatically go into that. So they tell us we've got the mean, got the standard deviation, so we've got the sample. Now they tell us let X be the EQ score of a grade 8 class. It is further known that the probability that the mean is at least, score is at least x is 0,0082. So determine the value of x such that you nearly get that probability. Okay, so what they're asking us is exactly the opposite that we've been doing the whole time. So they're asking us, there's your z of 0. There is a z value that we don't get, but what we do get is we get that piece that is 0,0082. So that is what we get. So we first need to work out the z with that. So let's write down this formula so that we see where we need to go with this. So in the end, I want to know what is the x. Okay, so we've got, so let's make that a different color. So let's make the x a different color because that is where I want to end up. So I want to end up where I know what the x is. Okay, so the first thing we'll do is let's substitute all the things that we already have, that we know, into this formula. So we don't know x. We know what the mean is 80. We know what the standard deviation is. Standard deviation was 20. We know what the sample size is. The sample size is 56. They don't give the z to us, but they give us the probability. Okay, so they give us what that probability is. So we again can decide two things. Do we go and work out the positive z? So we need to get to the positive z because we want that small area. But do we go and look at what the negative is and then just say, well, we know it is symmetrical. So if I get this small area, then I'm happy to just say that is the positive. So let's first do that and see what we get. So we're looking for a probability of 0,0082. That's why I said it's the inverse, because we're looking for the probability of 0, what is it again? 0,0082, 0,0082, 0,0082, 00. Yo. Okay. Minus 2,39, 2,39. Okay, cool. And it will normally be there, so it's just, and it's like, let's quickly, I don't think there's even a pattern. Let's quickly see the patterns in this. So there was 0,08, 0,06, so you can see it is going bigger,
Is
then
it not 0? Is it not minus 2.4, the first column? Minus 2.4, the first column.
okay, so that's also, oh, wait, you're right.
Yeah, 0.008.
0.82. I say
Yeah.
thank you. So again, how easy it is to make that mistake. Okay, so perfect. There it is. Minus 2.4 is the 0.0082. So let's look at, then on a positive side, it will be positive 2.4. Okay, so now at least we know what our Z is. So let's quickly work that out. Ugh, nice, again, not a nice sum. So 20 divided by, oh, square root of 36 is 6. Okay, so it's actually not too bad. So that will be, now I'm running out of space, so let's quickly move this one. Let's crop it and move it up a bit. So if I then say I need to get rid of that, I need to multiply both sides with, what was it, 3,333. So so 2.4.
I must drink careful. What I call?
So 2.4 times 3.333 is equal to x minus 80. Let's just, so we're working now on this side. So 2.4 times that gives us 8 is equal to x minus 80. And then to get rid of the minus 80 on this side, we need to move it to the other side. So we will plus 80 on both sides. So the final answer then is x is equal to 88, which is option C. So again, it is very much similar to that one that I showed last time, where, and we're going to do another one like that, where we got the number of students, we've got the popular, or the probability, where we got the number of students, and we nearly needed to work out the whole class setup. So just again for this one, and I will make sure, I don't know if there was one of these in the assignment prep that you guys shared with me, but if not, I think this is a very important one for you guys to be aware of, and I will on Thursday again include something like this. Okay, so yeah, that, and it's normally not in any of the traditional exam papers from pre-COVID, there's not a lot of these ones that they ask it the other way around. So also sometimes very difficult to get examples of these. So whenever, and even if your assignments are different, in the end you normally get feedback on the assignments, but also take us a few screenshots on if you're doing on a laptop, that and share it with me, that later on when we do your exam prep and all those kind of things, I will bring in all of those questions as well. I know during the assignment they don't want you to take pictures and share, so don't do that, but a print screen and you put it in a Word document and later you share it with me, by all means do that, and I will use that as exam prep examples as well. Okay, so yeah, so this is very similar to the one we did in study unit 6 as well, where they tell us, and let's just make this, let's just crop a bit, let's make it, and you guys can see this assignment was was a lot of questions on EQ, and obviously you will also see in your assignment there's always sometimes a theme that the lecturer picks, and so this one was a lot on EQ. So let's look at this one. So emotional intelligence core, so very much similar. If you look at standard deviation, normally there's the mean of 80, standard deviation of 20. So nearly again using the same information. If there were 1,997 learners with scores more than 97, how many students took the EQ test? So let's again look at, so interesting here, and also be careful, and I think it goes back to when do we use which formula. Nowhere here was mentioned about a sample. So normally distribution, so no sample being mentioned. The sample is the total population. We not working with a sample here. So they again in this one said, let's just put the 0 there. If there were 1,997 students with scores higher than 97, so scores higher than 97, so when we work out this probability, so if we get the Z here, that probability that we will get there because of the Z, that will be equal to 1,997 students. Okay, so then we will need to basically say the 1997 divided by that probability to get the total. So when I look at certain options, and this was from a previous student, but if I would have guessed, I definitely would not have guessed option D, because if that piece is 1997, your total class is definitely going to be much bigger than 2059. Okay, so that will definitely not be the one I will pick. Again, if I look at that compared to the rest, I would nearly have set somewhere between A, B, and C will be my answer. Again, 5903 feels too small. If that is a quarter even times 4, I'm already there. So it just feels out of sync. So let's see what the Z is. So 97 minus 80 is 17. And let me just make sure my maths without a calculator is not that great all the time. So 97 minus 80 divided by 20. So our Z that we're looking for is bigger than 0.85. So we're looking for that Z that is 0.85 to get to that probability. Okay, so now again, we can rather say, let's look at the negative Z, that is minus 0.85 to get to this area, because that is exactly, must also be 1997 students in there as well. So let's go minus 0.85 minus 0.85. Sure, just want to so why didn't it underline it? So then let's just highlight it. Okay, is it that one? 0.0322. Sorry, 0.85, not 185. Big difference in those two. 0.85, so 0.1977. So 1997 divided by 0, let's just make 100% sure, 1977. Okay, and if we do that, 1997 divided by point. Yes, we get 10101 students, point something, but approximately 10101, which is option B. So again, why I wanted to show this one is it's not the traditional way that we normally do it. The traditional way, and a lot in the study guide, is also we nearly tell you guys that we've got the X, we've got the mean, we've got the standard deviation out of study unit 6, and this is a lot in line with study unit 6. Then we tell you, okay, well, you've got that, you go to the Z, you work out the probability. The same with the previous one, the standard way is rather to say for you to work out that probability. So, and like on the chat or shared, there is probably a question in chapter 6 that you need to work out the X like we did here. So we could have worked out the X as well. So in a sense, they've given us the X, we needed to go much bigger here. But again, they could have asked us to work out that X the same way as they've asked us to work it out in the question 14 as well, or the slide 14. So I think that for me was the two important ones that I wanted to show you again. Is yes, there is the normal way. The normal way is where most of your questions is going to be asked in the exam, but there is always this one or two that is different, and it is nearly in the end those are the ones that can make or break it for you in the exam. They're not, again, the exam is not going to be that everything is like this question, or everything is like this question. It is your exam and your assignments is most of it is the traditional types of questions, where then they throw in one or two of these questions. But again, your assignment, I think now is around 10 questions. I think they've made it now 10 if I am correct. But so to get two of these questions is the difference between getting the 8 out of 10 or 10 out of 10 or 6 out of 10. So it does make a difference on your mark in the end if you get these difficult ones correct as well. Also, you guys would have seen when you get your marks, it's not as simple as there's 10 questions, you got it right or wrong, because then you will all get marks that is 10, 20, 30, 40, 50, 60, or 70, 80, 90, or 100%. But you will sometimes get a weird percentage of 82 or 76 or something like that. So what they also have built into the questions, and you might have seen it in some of the responses, is you get 1 out of 2 marks. So a perfect example would be, where was that one that was a perfect example would be this one. So if you got it right, you would have gotten 2 out of 2. If you set one of these, you probably would have gotten 1 out of 2 or a half out of 2 or something like that. Or it might have been, for this one, you get 4 out of 4 as how they add this one 2 and this one 1. So it might be when you get feedback on your assignments, it might be that you suddenly see, I got it wrong, but I got 1 mark or something like that. So it is because you picked something that is nearly on the way to the right answer. So also just be aware of that. So it's not that they randomly now suddenly just have given you 1 point because of the attempt. It is actually also there, and I don't think they've told you guys, but it might. So when you do the second attempt, because they don't give you the answers, but that must then give you the hint that you have done something right, but you still need to just do something more just to get to the right answer. Okay, so if I don't know if you guys have picked it up in your feedback and things like that, but definitely there is not that you all your marks is rounded. You will get these weird numbers in between, and it is because some of it they allocate it as 4 marks and you got maybe 2 out of 4 because some of the things that you did were nearly in the process to getting it right. I hope that makes sense what I said, and I hope it is like that still in the things that you guys have been picking up as well. Okay, so that is the session for tonight. What I will do is I will share the recording with you guys. I will share the presentation. We will then also have a session on Thursday where I will go